Dr. Silver, please introduce yourself and tell us a little bit about yourself.
Okay, well, I'm Dr. Sherman Silber. I have a very well-known infertility center in St. Louis, Missouri in the United States. And I think I could be the longest, oldest, still practicing IVF doctor in the world, still living. And I've followed this from the very beginning. But I'm a clinician that does both the male and the female, so it's unusual. I trained as a urologist, but I do all the gynecology as well, all the female infertility. And I also am an embryologist, although embryologist is becoming so much more complicated now than it was, say, 20 years ago, that I don't do the embryology anymore. But I was one of the early, you might say, pioneers in the whole field, starting with microsurgery and then to the present day with vitrification that Dr. Kuyama pioneered. And so I've been a friend of Dr. Kuyama ever since the early days when he first developed vitrification. And in those days, in the early days, we had a terrible dilemma when we had too many embryos, because we knew that if we froze them with freezing techniques at that time, that we'd have a very low success rate. So therefore we put back too many embryos, and we had multiple pregnancies that were dangerous, and that's what we all did. That was what everybody did in the 80s and 90s. And because you didn't want to waste those embryos, and if you did slow freezing, the results were terrible. But vitrification changed everything. So I was with Masa in those early days when he changed the world. That's a short answer.
Right now you are working on some research.
Yes.
Why didn't you tell us a little bit more about it?
Okay, well, there's a number of research projects. First one, we started freezing ovary tissue in cancer patients in 1997. And that was because their cancer treatment, their bone marrow transplant, their chemotherapy, their radiation was going to sterilize them. And so in 1997, the idea was, let's freeze the ovary tissue. And that way we can transplant it back to these patients later. Maybe 20 years later, they've been cured of the cancer and they want to have a baby. Now, we didn't have vitrification at that time, but the slow freezing methods worked because the eggs inside that ovary tissue were very tiny and they weren't developed. And so they were able to be successfully frozen with the old methods of freezing. That's not true of eggs you get for IVF or embryos for IVF. It was just true of the ovary tissue. And that was the very beginning. And I told patients in 1997 that I didn't think this would really work because we are afraid of transplanting cancer cells back, and we have no way of doing in vitro maturation of the eggs in that ovary tissue. So we really can't do IVF with it because we certainly don't know how to do that culture. And so I said, but it's all we can do for you now. And now, years later, 26 years later, we have so many of those patients that we did this a long time ago that are pregnant with, have many babies. I think the most, one woman has 5 babies from that ovary tissue we froze in 1997. And it lasts for about 10 years, and it absolutely is very, very successful. We never dreamt it would be. So the research now is not only to transplant that frozen ovary tissue back to the woman, but also to take the eggs within that ovary tissue, mature them so that they can be used for IVF. So that gives them 2 possibilities: transplant the tissue back and get pregnant that way, but also they've got eggs that we can, from that tissue, that we can transplant back. Now the question everybody would ask is, well, we transplant back the tissue, aren't you worried that cancer cells will be transplanted back? That's everybody's worry. So far we haven't had that problem. Cancer cells don't like to reside in the ovary cortex, but it is a risk. And so research now is on getting these eggs to mature and be good for IVF so that we don't have to have the slightest fear in our mind that we'll be transferring cancer cells back. So that research sort of stemmed out of the fact that we're actually trying to make stem cells from skin biopsies and then turn those stem cells into early egg precursors, which we call PGCs, primordial germ cells. And then the next step would be to convert those PGCs into actual functional oocytes. Now in the mouse it's successful, and baby mice. So it for sure is successful in the mouse. So what we're trying to do now is translate that to the human. And I think I'm guessing in 12 years, maybe 15 years, maybe 10 years, we'll actually be able to do that in the human. And actually, when a woman is completely out of eggs, in fact, as a parenthesis, we have 55-year-old women we've made PGCs out of. They have no eggs, but just from their skin biopsy, we've made primordial germ cells, which is the first step towards egg. So I think it'll be successful, but maybe it'll be even 15 years before we can really do that with humans.
What is your happiest memory from this work?
There were so many happy days. Such a question can't be answered. We have so many patients that thought they would never be able to have babies. Their eggs or their tissue, their ovary was destroyed by their cancer treatment. And nowadays, 90% of women, even with young women with leukemia, will survive. And so the cancer survival rates are fantastic, particularly for young women with cancer. But what really makes them cry is they can't have children. So all these women were women that assumed they couldn't possibly have children. And then to see them pregnant and with their babies is thrilling. I took videos beforehand when we were talking to them back as far back as 1997, telling them that we didn't think this would benefit, but maybe it would. Who knows? There's a 1% chance maybe this will work. We're working on the research, but we don't think it will work, so you have to know that before we do this freezing. I don't want you to get your hopes up. We have to be honest when we counsel the patients. So they thought there was no possibility, and I thought there's no possibility. But then to have them come back 25 years later with their babies is really fantastic. So I think that was what happened with vitrification. So Dr. Kuyama has on the wall here the various steps in knowledge about vitrification beginning in 1940 when it was first theorized, because no one would ever dream you could freeze eggs or cells and they'd survive because the water inside the cell will become ice and ice crystals expand, and so that would kill the cell. So with the technique that Masashige developed, we've done this experiment. You can take an egg and you can freeze it and then thaw it and then freeze it and then thaw it, and do that 25 times in a day, and there's no damage. You can freeze and thaw it, freeze and thaw it, freeze and thaw it, just to test the resilience of the system, and it works. There's just no damage. So you can imagine what that means. If we're doing IVF and we have extra oocytes, we can just transfer one embryo and freeze all the others, and we don't lose anything. And if they don't get pregnant from that one embryo, then we've got another embryo next month that we can thaw and put in. Also, most women are putting off having babies now until they're 40. And so now we can just freeze eggs when they're younger. And they come back 15 or 20 years later, and they have 25-year-old eggs that are very fertile. And we could not do that before this vitrification. It was impossible. Because embryos, you'd get a few to survive with slow freezing methods, but you couldn't get any eggs to survive because they're big cells and they're in a process we call meiosis, which means they're attempting to divide, and the chromosomes are in a very delicate structure in the cells we call a spindle, and that delicate structure will be damaged by ice crystal formation more than an egg that isn't dividing. And so eggs always they were impossible to freeze with the older methods. With vitrification, we freeze eggs very successfully. And like I said, you can freeze and thaw 25 times or more in a day and do no damage. So that's the exciting thing. We can't vitrify our whole body yet. Maybe someday we can, though.
Do you have any comments or word of encouragement for those considering a career in gynecology or fertility medicine?
Well, yes, everything is exciting. I mean, you could become an astronaut, or you could become an astrophysicist and try to figure out what happened in the Big Bang and how the world was created. There are all kinds of interesting things one can do. But it is pretty exciting to actually see this little cell turn into a human being. I mean, that's pretty thrilling. So I think the most important thing is you want to choose something that you have a passion for. If you're too logical about your career choice, you might not be happy. You've got to go with what seems really exciting and have that passion and that purpose. But if you start being too rational about it, saying, well, this will give me a 20% chance getting a job, and this will give me a 30% chance, and this will make me this much money, and this will make me that much money, you're not going to be happy. If you go with what thrills you, then you'll be happy. I'll quote Steve Jobs. He gave this famous speech at the Stanford commencement. What he said was, with him, he just pursued what seemed to excite him at the moment, which oddly enough was calligraphy. He was really excited by different ways of writing letters. And that seemed very strange. And he took calligraphy courses in college. And he always thought ahead. And what he said in the Stanford speech was that you just go with what thrills you at the moment. And ultimately, he came up with the Macintosh, which really transformed computers. So, as he said, you may have a long-range plan in the future, but it's never going to quite turn out that way. Pursue what seems exciting now, and there'll be different paths and tributaries that open up as you pursue what's exciting you. And eventually, you'll reach a point where you can connect the dots later and come up with things like iPhones. So that's what I recommend for careers for young people. And I think if you just look into reproductive biology, you'll be fascinated by it, how this little tiny thing, becomes a person. Is pretty thrilling. It's hard to get bored.